Hey everybody, welcome back to another game development live stream. I'm Geoff from Lost Decade Games. Sorry I missed you guys last week. I had family in town and so was visiting with them. But we're back for another episode. Thanks for joining. And again, we're going to be doing some Unity 2D game development work using assets from our game of Wizard's Lizard. Still kind of in the process of prototyping and figuring out all the different things that Unity has to offer, as well as prototyping some new stuff for upcoming games. You also notice that I got a new tiger hat. I got this at the San Diego Zoo when family was visiting, so it's pretty cool. I call it the Tiger Hat Light. It's a little less hot in the summertime than that big one with the crazy arms and stuff. So that's kind of nice. We'll jump into chat real quick. First, nice, Joe. Thanks for joining. Since I was kind of out of the office, so to speak, I haven't done a whole lot of work since the last time we streamed. A few things have happened though. Started rewriting a lot of the dungeon generation and stuff like that. Also working on some new animations and stuff like that. And Matt has been hard at work with some new graphics, which we may or may not get to today, but it's kind of what's going on. Let's start and just jump right into it. One of the things that I'm working on today, this is my task list right here, things I want to tweak, bugs I want to fix, and then some new stuff that I want to get back into. One of the big things I'm working on right now is dungeon generation. And this is something that I sort of taken several passes at. It's a core part of a Wizard's Lizard, and really any kind of dungeon crawling game with procedural generation, is how you lay out your map. And there's a lot of different ways to do it, and there's a lot of subtleties that go into making sure that the rooms connect the way that you want, and you provide interesting layouts for the player to explore, and also that your end room or your goal room is perhaps a certain distance away from your player. One of the things that I want to experiment with is the idea of what I'm calling mechanisms, which is putting kind of switches and doors and blocks in the place of the player so that they have to traverse the dungeon in such a way that they have to encounter these puzzle elements and either flip a switch or pick up a key and then take that to a certain room or something of that nature. I've actually been drawing a lot of inspiration from a series of posts by a guy named, I'm probably going to butcher his name. His name is Tom Coxon. He is a developer on a game called Lena's Inception, which is kind of a 2D Game Boy Zelda-esque procedural generated game. He has some open source code where he talks about how to generate kind of arbitrary key and lock puzzles with dungeon generation. So I've been reading a little bit about that, and I'm kind of taking my own approach to what essentially is the AWL dungeon generation with this kind of a format in mind, and that format being you want the player to have to traverse the dungeon in such a way where they have to find the key or the switch, hit it or pick it up, and then go to the next kind of block in the puzzle. So let me just first talk a little bit about how our dungeon generation works, and then we'll take a look at it. It's actually pretty simplistic right now. What happens is that we create a dungeon of rooms, which is a certain width and height. And then one of the things I like to do, and I found that works best for me, is creating what I call a critical path. And the critical path is essentially the path which the player has to take to the dungeon, perhaps. There could be alternate routes, but there needs to be one kind of core path so you can get from A to B. And the way that we're doing that right now is by selecting a random start room in this grid. And then we have a setting that controls how long that critical path should be. And once once we have that first start room, then we get all of the what I'm calling inactive neighbors. And inactive neighbors is really just any room that is not active adjacent to the current room that we're in. And so not active means that it's not currently a room. It's just an empty cell. And so it gets a list of those, and then it sorts them, in this case, by the number of open neighbors that they then have. Oh, cat says hi. And what that does essentially is it makes it so that the critical path chooses to go towards the areas that have more room to expand. And this is something that later on I'll probably add a little bit more of like a heuristics type approach to, so that it's not, you know, as predictable. Maybe sometimes it'll pick to not go towards a wall based on some scores. Anyways, and so then it connects the current room to that next room that it chooses, and then it iterates the room count and then keeps going. And so this while loop right here basically just creates that critical path. And when it gets to the end of the critical path, it marks the last room in the path as the end room, and then the parent of the end room as the challenge room. And the challenge room is really just a place where you can put a boss or something. And so for Wizard's Lizard, you know, the end room of the dungeon is where you get the rewards like the treasure chests and whatever else, and then the challenge room is the boss. And then next there's this other little function that creates some extra rooms. So once you have the critical path, it then goes through, and really all it does, it's pretty simple, is it just aggregates a list of all the rooms that are not the end room or the challenge room, and then it adds some extra rooms off really any of those rooms kind of randomly until we've hit our room limit. So while the room count is less than the room limit, it goes through and it picks a random room, finds the inactive rooms near it. If there are any, it picks a random one and connects it, and then rinse repeats. So let's take a look at what this looks like in Unity. It's something, I don't know if I showed this on my last stream, but I found a cool way to visualize the map. So there's this gizmos toggle when you're viewing your game in the Unity editor, and it lets you kind of see some of the various game entities. So you can see right here there's this light source, and it has like a light icon on it. And if I pick up this fire wand and I shoot some fireballs, you can kind of see that the fireballs have that light icon on them, or the light gizmo. And what else you can do is you can also like highlight certain game objects and see what they've got going on. So you can kind of see here that, like, you know, Raga has this hitbox, which is a circle, and then this blue thing is actually his audio emitter. Also, though, you can see the colliders, and so these, we're using sprite tile for the map, and you can see all the different polygon colliders that sprite tile creates for our map. It looks a little funky just because I'm not exactly sure the algorithm it uses to create these polygons, you know, because this whole wall is essentially is collidable, and so, you know, you would expect that maybe this whole block would be one polygon, but, you know, it's not for whatever reason. So that's kind of just the way they do it. But it's really helpful to visualize what things look like. The other great thing that I've been able to do is to, you know, go into the scene tab, and I can zoom out and turn on the colliders, and I can kind of get an idea of what the map looks like as I'm generating it. So this has been pretty helpful. It's also kind of fun because you can like scroll and zoom around. You can see the different rooms filled with stuff. If you remember, this kind of sewer vent thing is our exit. It's our warp zone out of here. So that would be the end room. So you can kind of see that we start in this, I think we start right here. And you can see that the path to that end room, I guess we probably started up here in this room probably. But you can see that you can go up and to the left up here, and then there's kind of this dead end. There's a dead end here. You can go down, and there's a couple more. There's a dead end here and a dead end there, and then the end room is right there. And so that's kind of cool. It's very helpful for debugging and figuring out how we're generating stuff. I think that the other thing we wanted to do today is something that Matt has been kind of pretty happy about, which is connecting rooms a little more, not arbitrarily, but you know, creating a little bit more connectivity around the room so there isn't just a single pathway. Because if you look at what we have so far, there's still kind of a very, you know, one kind of dimensional path through the level. You know, you start, if you're here, you can go up and down there, and then you hit a dead end and you have to go back. And if you go this way, you hit a dead end, you have to go back. And there really isn't any interconnectivity of the various paths between themselves. And so that's something that we want to correct. Catch with ooh, live chat. Yeah, the cats make the streams much better. Let's see. Yeah, the overlay is really useful. Yeah, the WebGL export for Unity is pretty heavy. We actually had one of our Lostcast listeners named Dan Nagel. He did a comparison of just a really simple app and found that the WebGL export was really, really heavy. It's still in beta. So, you know, hopefully that stuff will change. Again, it depends on what your targets are. You know, I think that for us, the web export isn't really that big of a deal right now because, you know, we primarily sell most of our games through Steam and the Humble store, and then through our own site through the Humble widget. And so, in that case, you know, we won't be using WebGL hardly at all, if at all, to export our games. So not a big concern. It's something we thought a lot about when considering the move to Unity. So basically, I've actually been doing a lot of work on AWL, the live version that's on Steam right now. Kind of using it as a test bed to test out some ideas for dungeon generation, and that's where some of this latest iteration of dungeon code has come from. And so what I'm going to do is I'm going to open up that file. You can see it's still called CryptRun from way, way back. Almost, what was it, 2 years ago? Almost? Thanks. And let's see. So we have the zone layout file here, and this is all JavaScript. And this is essentially what creates the layout for Wizard's Lizard. So it kind of has a very similar setup. It creates a goal path, it creates some challenge rooms, and then it creates some more interesting rooms off of the critical path, and then it also creates some extra rooms. So that's something we want to do here as well. So we're going to go ahead and create a new function. So we'll say create connections. This is what we'll call this for now. Naming is always hard stuff. I always agonize over that kind of stuff, but right now we're just going to go with what's simple and easy. So essentially what this function does is it wants to create a certain amount of connections if it can. It's kind of like an upper limit, but it doesn't have to. You know, because of the way the dungeons are generated, there may not be an opportunity to connect any rooms. So if we look at this dungeon that we have going on here, we'll zoom out a little bit and scroll. Where is it? There it is. So if we look at this dungeon here, you can see we start in this upper left, and then we have essentially what I would guess would be in one of the extra paths, and that's coming from the top and going here. It's like a little two-room thing right there, and then you kind of go across the top. Oh no, never mind, I lied. This is the one that ends in a dead end. It's hard to see sometimes because of all these little polygons, but essentially there's a path right through here, and there's a dead end, and there's a path down here which ends in this dead end, but there is a pathway right here and then it kind of goes down to the exit room, which is right here. So the critical path here would be starting in the top left, going down one, over to the right, down, down, and that's where we end up. And then we have kind of these little offshoots. And so in my algorithm, I say that the challenge room and the end room can never have extra connections, because I don't want, people having, multiple doors into the boss room, and then obviously you don't want to be able to circumvent the boss either. So those ones are kind of off limits, but, you could create, for example, could create like an extra connection right here between this top room and this kind of middle room, or these two rooms perhaps. Right here would not be a legal connection, and right here wouldn't be either, because those rooms kind of border this challenge room, which is where the boss would be. And so, but depending on the generation, it's possible. Sometimes it's unlikely that this will happen, but it's possible that there wouldn't be any opportunities for extra connections, just depending on how the map gets generated. So this might be an interesting. Well, I guess we could create a connection right here too. Anyways, we'll go through that code and see what we can make happen on that front. So the first thing I want to do is I'm actually going to take out this little piece of code and put it somewhere else. So I'm going to actually create a list of rooms that we can use, kind of a reusable construct, because we have a couple instances where we want to have this pool of rooms that don't include the end of the challenge room, and so that's what we want to populate here. So we're going to take that code out, and first we'll just pop it in here, and we don't need that anymore. And let's see. Yep, that looks good. So basically what this is going to do is this is going to aggregate all of the rooms that exist on the critical path, and except for the end and the challenge room, and allow them to be parent rooms for the extra rooms. And so then when we're creating extra rooms, again, it kind of goes through those rooms and picks random ones and creates children. And then it also adds those children to kind of the pool of rooms so that they themselves can become targets for that stuff too. So we're going to do the same thing here. It's a little bit of a different loop here because, in the first one, basically we say, while the room count is less than a certain amount, pick a random room. That doesn't work as well with this particular step, just because, like I said before, it's possible that there won't be any connections that can be made just based on the rules. We're actually going to have a couple more rules for this particular prototype than before, because I've also added in this idea of a key level. And I'll get to the key level a little bit later on, but the key level is essentially an indicator that tells me which areas of the dungeon require a key. And so we know that if we're on key level 0 and there's a room where it goes from key level 0 to key level 1, that's where we need to put a block, and then we need to put the key for that door somewhere in key level 0. So the first thing we're going to do is we're going to shuffle the rooms that we have. And just to kind of go into that real quick, a lot of explaining going on today. It's just a very quick function that takes a list and shovels it using what's called the Fisher-Yates method. It's just a method of shuffling an array, randomizing the contents. So basically what we're going to do here is go through each of these. So we're going to say for each room in rooms. We're going to iterate over that list, and then we're going to say list of room neighbors is equal to dungeon dot neighbors. Oops, actually capital actually. Neighbors, and then we pass in the room, and that's actually just a function here in this dungeon class that returns all the neighbors, orthogonal neighbors of a particular room. So once we have that list of neighbors, we're going to go through and figure out which ones are actually valid for our purposes of creating connections. So let's create another for each, and we'll call this room neighbor in neighbors. And then we're also going to need to create a list here. So we're going to create another list of rooms. We'll call this valid for now, equals new list, room. And then we have a few pieces of criteria here that we want to make sure. One is that it is active, which is true, and it's not end or challenge. And you kind of see that same logic here in our JavaScript version, where it says, if it's an object, essentially, and it's not the end and it's not the challenge, and it's not already connected to this room, that's actually something else we have to watch out for. So let's take a look here. So if neighbor.active and neighbor.type is not equal to end, and neighbor.type is not equal to challenge, and this is going to be kind of a big set of ands here. Valid.add neighbor. So that's how we're going to populate that list. And then once we populate it, we're going to say if neighbors.count is greater than 0, then we're going to pick. So we'll say room next is equal to random.choice from neighbors. Random.choice is just another kind of generic randomization function that I've written here that takes a list and just picks a random entry. So it's going to pick one of those, and then it's going to call dungeon.connect from room to next. And then I guess we're going to need a counter here too, so we'll say int connect count is equal to 0. And this is going to, we're going to say connect count plus plus here. We're actually probably going to have to change this to a for loop just because we're going to need to control it in a little different way. So we're going to say int I is equal to 0, and then I is less than rooms.count, and connect count is less than connect limit, and then I plus plus. And then we'll say room is equal to rooms I instead. Just so basically once we've hit that upper limit of room connections, then we'll stop. And we'll make that a parameter up here, so we'll say public int connect limit is equal to, say 2 for now. It's the max number of random connections that the algorithm will make. So here we need to do a couple more things. One, we need to make sure that it's not the parent and also it's not a child. So I think actually we can do it just by examining the parent of both. So if we say and room.parent is not equal to neighbor, or it's actually if neighbor is not equal to room.parent. So it's saying if the current neighbor that we're evaluating is not the parent of the room we're in, and the neighbor's parent is not the room that we're currently in. So if those two rooms aren't already connected via a parent-child relationship, then they're a valid choice for connection. So let's take a look real quick, see if that works. So let's do a debug log right here that just says connect, and then we'll just give it a count. So this would be neighbors.count, just so we can kind of see what's going on before we actually do any of this stuff. So we'll comment that out for just a second, and we'll go in here, or run our project, add a range. That's always fun. That, I think, was a bug somewhere else that I haven't addressed quite yet. So we're going to ignore that just for the moment. So there's 4 potential connections. That's unexpected for some of these things. Oh, I know what we need to do. Well, I don't know, actually, that should be fine. What we're going to do anyway, though, is move this up out of here, and then we're going to say valid.clear each time, clear the list. So it's active, and it's not the end, and it's not the challenge, and the neighbor is not the current room's parent, and the parent of the neighbor is not the current room. Then we add it to the list. All right. Let's see what we got here. 3, connect 3, 4, 4. Seems a little bit odd to me because there's really almost no scenario where you would have 4 potential connections for a room. You know, at least one of those rooms should be off limits because you're already connected to it. So let's see if we can figure out what's going on there. And while we think about it, we'll just check in with the chat real quick. Oh, thanks. Yeah, it's Unity is it's kind of coming second nature to me. I've been using it quite a bit, so. I switched to Windows. I've kind of always used Windows off and on. I still kind of primarily use my Mac, but I do a lot of my Unity development in Windows just because for streaming, it's the Windows machine is a lot more powerful than my MacBook. So. All right, let's do some debugging here. So we're going to pick a random room, we're going to do a connection, and let's put a debug log here that says connect one thing I kind of miss from JavaScript's console is like the ability to just put a bunch of parameters as arguments to the function instead of having to do string concatenation. We'll say room.x plus room.y to room next.x comma, x.y. And then we'll take a look what we've got here. So 3 connections connecting 4,2 to 4,1. So let's take a look here. These maps are actually 5 by 5. So this would be, 0, 1, 2, 3, 4, and then 0, 1, 2, 3, 4. So we start actually at 4, 4. So this is going to be connecting 4, 2 to 4, 1. So we're going to be on this side of the x-axis. This is 0. This is 1, 4, 1 to 4, 2. Yeah, see, that's not right, because if we're making a random connection, then we should already have, there should already be this connection here. Room.parent. So I'm going to have to just take a quick look at how I implemented some of this stuff. So the parent is a room, and then the list of children is a room. Maybe this comparison is not working the way that I think it is supposed to be working. So we're going through the list of rooms randomly. For each room, we get a list of the neighbors of that particular room. For each of the neighbors, we make sure that it is active. It has a type that does not end and a type that does not challenge. And this, I think, is where the logic is breaking down right here. I'm not exactly sure why. So maybe we can try and attack this from a different angle and say maybe that neighbor.children let's see. I'll have to do a quick Google for a C# list index of. I think I know how this function works, but sometimes I have to be sure. Index of item, okay. So I think it's just index of, or actually I think contains is what I want. I really like the generic list constructs in C# actually. So I want to say, and it doesn't contain room, and room.children contains neighbor. Let's try that maybe. Maybe that'll get us closer to what we want. That looks a little better. So immediately we're seeing only 3 possible connections, which is, a lot more likely. So in this case, connecting 1, 4 to 0, 4. So again, we have an x of 1, so 1, 4, are we down here? So this is, this now has 2 connections, so this is kind of more what we're looking for. 1, 4 to 0, 4. So that makes more sense, right? Because now we have these 2 rooms right here that are both connected to other rooms and then now also connected to each other. Again, 3 rooms, though, doesn't seem likely for room 1, 4 because, it had to be connected to one of these rooms already. And if that was the case, then there really should only be 2 options. Let's say it was connected to this one already. The only valid connections that it could possibly make should be this one to the right and then this one to the left. Let's take a look. So the next one was 0, 3. And so 0, 3 would be this guy right here. And connecting 0, 3 to 0, 4. Yeah, see, that doesn't make sense either because that means that this room, without these extra connections, it would have been an orphan, which is not true. So maybe what we'll do is we will increment the counter without actually connecting them. Just so we can see. And then let's also debug the actual room. So we'll say room that we're looking at right now is going to be room.x plus room.y. So it's a little bit of a different stream. Usually I like to do a little bit more visual stuff. I mean, this is pretty visual because we get to kind of look at the level we're generating. I hate to get stuck on bugs though on stream. I don't know if that's very fun for everybody. But let's give it a little bit more shot and see what we got. Okay, so room 2-4. Which would be 0, 1, 2, and then all the way down here. So we start this one, and this one, see, this one says there's 3 connections, which is really just not true, because it's already connected to this guy, and there's no room over here at all. And so the only possible room that it could connect to would be this guy right here, which this one would be a valid connection because it's not the end room or the challenge room, which are right here. This is probably one of those cases where I'm doing something stupid and I just don't I don't realize it yet. So we will see. So we get a list of all the neighbors, and so that should already be filtering out. Oh, it filters out things that are off the map. I see. So if neighbor is active, let's see, add some more debugging here. Debug log, adding, we'll say neighbor.x plus neighbor.y. I bet Unity has some kind of step-through debugging, but I'm not quite that advanced with it yet. So we spend a lot of time in the console. See, that doesn't make any sense, right? It says we start at room 2-2, and it doesn't even add anything to the list, so how could there possibly be any neighbors? Oh, God. I'm so dumb. I wonder if chat's figured this out before I have. Let's see. Guess not yet, but yeah, so the C# list actually compares really well to an array. An array is really, it's really strict in a language like C#. It's not like JavaScript where you can just push and pop onto it. I mean, you can, but you can't resize it very easily, and there's not a lot of utility methods on the array. And so with the list in C#, you get all kinds of really cool stuff just by default. So we'll see if we can, if the internet wants to cooperate with me. There we go. But you can basically filter it, and you can see if things exists, if it contains certain values. You could find last index for each, get a range, get the index of, insert a range, remove all, remove range, reverse, sort. There's some stuff that the JavaScript arrays do here as well, but the list is really just a nicer construct to work with than an array in C#. The arrays I find to just be a little bit more rigid and less flexible than the generic lists. So I tend to use lists as often as possible. Anyways, I found my mistake, which was we were filling this list called valid, and then right here we were actually looking at the neighbors list, which is a different list. That's the list of all the neighbors. And so really all we have to do to fix this bug is look at the valid list instead of the neighbors list. And so now now this should work. Famous last words, right? I think it'll work this time though. Okay, so see connections 4. That is just not cool. So we're looking at room 3, 3. 0, 1, 2, 3. And then 3, 3 would be right here. This guy. Connections 4. Oh, I think, yeah. So I'm still, there we go. I need to, I think it actually worked. It's just debug logging the wrong value. Still looking at that list. The original list of neighbors. Okay. So now we're looking at room 1, 4, which is going to be this guy, I think, right here. And there are 0 connections that are possible, so it's going to skip that guy, which makes sense because, and that the reason is because this right here is the end room, which means this is the challenge room, which means it's an illegal connection, and it's already connected to these 2 guys on the sides here. So there are no possible connections for that room, so that's good. Then it moves on to room 3, 3. So that was 1, 4. So 3, 3 would be here. And it looks like it was already connected to stuff 2 because it says there are 0 connections. Then we get down to room 4, 2. So 4, 2 would be 0, 1, 2, 3, 4. And this would be 4, 3, 2. So it would be this guy right here. And this guy was probably a dead end off this one. Or this one, actually. And then it found one possible connection, which I'm assuming is this guy. And so it connected 3, 2 to 4, 2, which is like this guy to this guy. And so that actually makes it a little bit nicer, you know, traversal. So you can kind of come in and you can go up this way and around. It's kind of a nice little cul-de-sac or circle or something right in there. And I think that on that map, that was the only connection that was possible to be made because everything else was either already connected or the connection would have been illegal. We can kind of take a look at that a couple times and see. Oh wow, that's a really interesting randomization of the map. So we start here, and let's see if we made any extra connections. Yep, 3, 1. So we made only one connection again. So you can kind of see that depending on the map, you may not even have the opportunity to make more than 1 or sometimes 0 connections. So we can kind of remove some of this debugging because now we know that stuff is working more correctly, and then we'll just keep the connection debugger around. Oops. So it's a little less noisy. So this one actually made 2 random connections. It randomly connected 4, 3 to 3, 3. So 4, 3 would be right about here. And then 3, 3 would be here. So you can see now this room became like a 4-way stop instead of probably a 3-way stop before. And it gives us you know, in this case, it maybe made the goal room a little bit shorter. 1, 2, 3, 4, 5, 6. Maybe not. But you know, it kind of gives you a little bit more opportunity to, you know, you can either go down to the boss this way, or you can come up this way and down through here. And so let's just check out one more variation. I always spend a lot of time kind of generating, regenerating, and seeing what kind of different things we can come up with. I started adding in a little bit of kind of alternative templates too for the rooms that are less roomy and more hallways. And so you can kind of see it here with this guy, which I think looks really cool. Especially when you get into the scrolling map, you kind of get this feeling of a little bit less boxiness. We actually made two connections here, 4-4 to 4-3. So 4-4 would be the start room, and then 4-3, that would be this top room. So it looks like, 1, 2, 3, 4 that way. And then this became a random connection. But anyways, multiple ways to get to the same room is pretty cool. Let's check in the chat real quick. Yeah, so there's an array list, I think, in C#, which kind of acts similarly. But yeah, that's the big pain in the butt with C# arrays, just the generic arrays, is that you need to define how big they're going to be right up front, and then they can't change size, and so they're a little less flexible. I feel like the list in C# is actually closer to a JavaScript array anyway, or the array list. I actually haven't used the array list so much. I don't really know what the pros and cons of that are as compared to a generic list, but maybe I will find that out and talk about that next time, or we'll talk about it on LostCast sometime. So that's cool. We now have some random connections with our maps, so let's go ahead and check that in. Add random room connections to dungeon generation. Great. And so this is kind of where we're going to get back into some of the key and lock puzzle stuff that I've been talking about. And so what I've started to do is I've laid the groundwork with this variable called the key level, and then the rooms per key level. And essentially what this does is it just increments the key level every so many rooms. And so we can put a debug log here. Just to show that it's actually happening. But it only happens once in this level. And so for a bigger level, it could happen a couple times, or we could even put some constraints in there that would say, how many key levels, the maximum number of key levels. But the idea is that along the critical path, which would be probably this guy, but now we actually have two critical paths based on the random connections. You can either go from the first room 1, 2, 3, 4 to the last room, or you can go down 1 over 2, 3, 4 to the last room. And so if the key level changes to, if we go like 1, 2, 3, the key level will probably change right here in the challenge room for this particular dungeon. And so what we want to do is we want to put like right in here, this is like a doorway, it's a hallway. We'd want to put like some kind of blocking mechanism. And then somewhere else in these, non-key level 1 rooms, we'd want to put a switch or a key or what have you. But we do want to do is want to make sure, want to add one more requirement to these random room connections. We want to make sure that the key level is not different. So we want to say and neighbor.keyLevel is equal to room.keyLevel. That's going to further restrict the types of connections that can get made, which is okay. What that'll do is it'll kind of force the connections to be within the same key level, so it won't try to connect rooms across, far areas of the map, even if they kind of double back on themselves. So let's just take a look. That one's a little bit hard to visualize, but what we can do is we can up some of these numbers. just to get a bigger map, just to kind of get a feel for what things would look like in a larger area. I'll go to our scene. So now we're getting something more like this. This is pretty interesting. So you start over here, and then you've got, this is, you know, you can actually go to any of these rooms. And then you kind of come across this little area, and now you're like, you know, sort of in a different wing, it looks like. And then from this room, you can either go up or down, and there's a dead end here, and then there's a dead end there, and a dead end there. And these dead ends are places that would be really fun to put like secrets, things like that, because the actual critical path kind of goes up this way, and then over, and then this would be the goal room here. And in this particular map, this ended up being the boss room, which is, you know, later on we'll probably want to make it so that this boss room here doesn't have the opportunity to have this kind of, this weird template. So let's take a look. Oh, get out of my way, slime. So this is what I was talking about before, these kind of more hallway-esque rooms that kind of make the map feel a little less boxy. And so, you know, as I kind of keep iterating on this prototype, I'll probably add in some more variation there. Woo! Getting knocked around by spores. So this is another kind of different room. It's like more like an S shape or something. And then here would be our exit. Oh, second test map. Oh no, so scary. And the tile set is really weird looking. Oh, and the collision is completely off on the pits for some reason. Wonder why that is. It's probably just because I forgot to set the collider tile flag on these guys in sprite tile. This is what Matt. See, this is also not good. Why is this wall there? So this is helpful to kind of see that really shouldn't be there. I actually had this problem before, and I thought I fixed it, but it looks like maybe I did not. Which was that the level geometry wasn't getting cleared, or the collider geometry wasn't getting cleared when I loaded up a new level, so it looks like that's still the case. That's actually a bug in sprite tile as far as I can tell, so something I need to fix. This is kind of fun though. You can see, like, look at all these spores just flying out into nowhere. That is because this room geometry is like not there, the walls, and so it's just firing these spores out into, you know, who knows where, nowhere. Oh, they haven't made it this far yet. There they go. Oh no. Anyways, fun stuff. Whee! Yeah, I could just zoom in around these maps all day long. It's too much fun. Anyways, aside from that bug, although I should probably note this down, let's say that room wall colliders aren't cleared properly between wall transitions. I think it's a sprite tile bug. We'll have to figure that out, because that's not super great. Although, you know, not doing a whole lot with level transitions right this moment anyway. So let's see what we did here. Oh yeah, we made it the key level. disallow random connections between rooms with different key levels. Update stream.d. Awesome. All right, now let's talk about how we'd actually get our mechanisms into place here. So once we have, we can actually close that now. Once we have that tile map, the dungeon generation all done, that is largely just metadata, right? So all this code that we've been working on is really just the stuff that generates the metadata for the level, for the actual level. And then this file right here is what actually deals with creating the game entities based on the metadata, creating the rooms and the walls and all that other stuff, using that stuff. And so this is where it loads the map. And then populate rooms. This is where it iterates over the logical rooms. And so, it places the lights, it places decorations, power-ups. And we actually have this XML file that describes how and where things go, which decorations to use, which monsters to use, things like that. And this is kind of evolving over time based on the needs of the current generator. This is a different tile set that Matt has been working on. It's kind of supposed to be like an outdoor garden-y area. Still early times, obviously, but pretty interesting so far. That's kind of where these statues came into play. And depending on the type of the room, we have some special cases. So you can see here, then the start room, it puts the player start, and in the end room, it puts the warp. And then the default is just to fill it with monsters. However, we want to figure out a good way to message where the blocks should be. And this is actually something that's going to be a little tricky just because there are a couple things going on. For example, in these room templates, resources, data, rooms. So for example, we have this room right here which has exits on the top and the bottom. And what we would want to happen ideally is if the room above this one had a block, was blocked off, there's a different key level, then we would want to put a block here or there. So I think that the way that we'll want to do this is we'll probably want to use triggers. And I think that we'll want to use triggers based on the bit masking of which exits have or are adjacent to rooms with a higher key level, I guess. Or maybe a lower key level is the way to do that. So that the room in which the key level changes, that's where we want the block to be. So let's see if we can get that done. So let's take a look. One thing we do is we have this function that returns the exit flags. And really all this does is it looks at the neighbors, and if the neighbor is in the children collection for this room, it says that yeah, that room needs an exit, and that's how it knows which exits to use, or which room template to use. So maybe we can create something similar called key flags, and we'll give it the same kind of parameters. And really, you might want to like condense this somewhat later, but it's going to be very similar. We're going to look at all of the children, or all the neighbors, if any of the neighbors are a children, or are in the children collection, or this is the parent of that room. Well, we can probably do it a little bit differently here, so maybe we'll try this out a little differently. Maybe we'll say for each room in room dot children. So for all the children of this room, although we also want to well, really, maybe we only need the parent, because the key level is only going to change relative to the parent. So maybe we can just say if room.parent.key level is less than room.key level, then we're just going to copy that whole structure. It's probably a much better way to structure that for now, but I'm lazy, so that's what you're going to get. So we'll say room.parent, and then we'll say return flags. Get all this stuff. So basically we're saying here, if the current room has a parent whose key level is less than itself, which means that the key level is incremented going from the parent to the child, then we're going to take the offset between the parent and the child and determine which of our bitmask flags that represents. So what we'll do here is let's just take a look and say key flags is equal to is this dungeon? What do we call that? No, dungeon. Dungeon dot key flags for the current room, which is just room, and then let's debug log that. I'll say if key flags is greater than 0, because we only really care if there are any actual key exits. Then we'll debug .log key flags. Yep, let's try that and see how it goes. If room.parent is not null, There we go. Because a starting room actually won't have a parent because it is the root. So we're creating key level, random connections, key level 0. Key level 1. What do we call it? Or what do you make that debug? Key flags. Let's get rid of some of this noisiness here, so we can see if maybe things are happening the way we want. Key flags 8 and key flags 2. So let's also debug log the room, which is going to be room.x or room.y, just so we have a better idea of where this stuff is going on. Key flags 4 in room 5.4. Whoa. Crazy. So 5.4 would be 0, 1, 2, 3, 4, 5, and then 4 would be 6 by 6, 5.4. So like right here. Yeah, which is so key flags of 4 would be correct, because the way that I've done the bit masking is that north is 1, east is 2, south is 4, and west is 8. And so in this particular case, that would actually be correct, because we have the end goal room here with the warp, as you can see, that little sewer thing, which means this would be the boss room, or the challenge room, or whatever. And then this is the room in question, 5.4, and then it looks like this is where the key level got incremented, which means that this hallway right here, the southern exit, number 4, would be the one to get the block. So the next part of this is going to be to actually put triggers on the map where we want these things to be, and hopefully we can just do this pretty quickly. So I'm going to go through each of these templates, and we're going to put a trigger in the place where we want these things to appear. And I'm going to use kind of a I guess like a numeric namespacing. The way that sprite tile works is that you can only basically add a integer value as a trigger to each tile. So we're going to start with 200, and 201 is going to be the top, 202 would be this side, 204 is here, and then 208 is here. So basically it's going to be 200 plus the key flag, which will make that really easy to deal with. So here we'll have 202. We'll save that. And there's only about 15 rooms, so it shouldn't take very long. So 201, 202. This one will be 204. Oops, this will be 201, 204. This part is probably not the most exciting, but hopefully it gives you an interesting idea of how this kind of stuff might work using a system like sprite tile or something with similar capabilities. So which one are we on now? 6. Open 7. 201. 202. 204. Halfway done. This one is going to be 208. 8, 9, 201, 208. Oops, 208 and 202. You can see I have this 100 thing down in the corner too, and the 100 trigger is actually a trigger that tells me to fill this whole interior space with like a random room template. So any of these kind of room connections with the various exits could have like a big pit in the center, or like some columns on the side, or various pieces of geometry. There's actually a few different 10s here, so we can put a 208 there and a 202. So this is the 10 room template, and the 10 room template gets randomized between A, B, and C. It's either like the long hallway or kind of the S shape or just the big room. That's kind of the plan for most of the templates, is to have these variations that can make it a little more interesting, although there's only a couple that actually have those variations in place at the moment. 202. Almost done here. It's 11, 12, 208, and 204, 12, 13, 208, 201, 204, and then 13, 14, almost done, 208, 204, and 202. Last one, number 15. 15 is all exits, 201, 202, 204, and 208. Who's tired of me saying 208, 204, 201? No one? Okay, good. Okay, I think that's good. So what we're going to do now is basically we're going to say place room objects in room X, room Y, which is a function I wrote. And then we're going to say triggers dot. Well, let's not do that now. Let's just say 200 plus key flags. So it's going to be like 201, 202, 204, 208. Yeah. Although I guess like if we might have to refine this if there were more than one exit to the same room, but hopefully that's not really going to happen right now. And then we'll just say we'll hard code this right now to let's see what those things are called. What do we want to use? We want to use the objects. Yes, objects block toggle. So we'll just say objects block toggle. Oh, does this need to be an array? It might. It might. Place room objects, string array, yes. So we'll just say string array blocks equal to new string array, and then objects. C# actually does have some kind of like, what would be similar to object literal syntax in JavaScript. It's a little more verbose than JavaScript, but it kind of works very similarly. You can see I'm doing some of that stuff right here. By kind of initializing a dictionary here with all of the room templates, and then a similar thing for the insert templates. Actually, I guess I don't need this new thing. I think I can just do this, right? Because this function expects that. let's see. It's possible that it might work. I'm not super confident. I probably shouldn't say that. Oh my god. What have I done? Let's get that hand tool back here. That's what I'm looking for. Okay. So we have a key flag is 8 in room 22. Oh, there we go. Look at that. So right in this doorway, we've got this blocker where we can't go any farther. And let's see. That actually prevents us from going to the exit. So we can see that the exit appears in this room right here, this little warp zone. And the only way to get to it is from this room. And there's a block sitting right in the middle of that entryway there. So if we were, let's actually just change the change this to be a little more sane in terms of number of rooms. Uh-oh. Oh man, we have no keys now. Let's just turn that down a little bit. Still? No? Okay. There we go. So now I've actually got, yep. So here's our exit. Here's our challenge room perhaps. And then here's where player starts. So we can see that if we head over this way, making our way down. Oh, there's now a block in our way and we can't get to this next room. Obviously that's some Geoff art right there. That block will hopefully look a lot better at some point in the future. But that actually kind of gives us the beginning of a little bit of a puzzle aspect to our dungeons now, because now that we can't get through this area, we need to add a button. And the actual button and the block toggle mechanisms already work. I've gotten all that code and that linkage figured out previously. Now really it's up to just basically spawning them in the world in intelligent locations. And so in this particular instance, what we want to do is, since this room has the block, we'd really want to spawn the switch or the key for that door somewhere else out here. So since the player kind of starts here, it might be fun to have it either in one of these two rooms. Either this guy or this guy. This guy would be the most optimal, just because it's kind of this dead end up in a ways away, so you have to kind of figure out where you're going. Maybe you meander up here, you find a key, you find a switch. I guess there's because of the room connections, there's that too. So none of them are terribly far away, which is okay. Most of it's just really about promoting exploration of the dungeon and kind of making it interesting to traverse instead of just room to room to room to room with no obstacles in your way. For the actual button placement, let's catch up with chat real quick too. See if oh wow, lots of chat. Love it. Tiger hat knowledge, yes. Yeah, thanks. I like the hallway rooms too. Hopefully, there's going to be a lot more interesting room design as I keep iterating on this. Some kind of circular rooms, or just kind of dead end rooms that just have interesting shapes to them. Let's see. Yeah, I got some Twitter love on the stream. Yeah, I agree. Adam is not super great. It's okay, but it's really just not as fast and lean as Sublime Text. Um, let's see. Wow. Yeah. So the next step here is going to be to place the switches, which will then open the door, and maybe that's an exercise we will save for next time. I like to keep this stream to about an hour and a half. I was kind of thinking more of an hour, but really just kind of got into the flow and made some progress. So let's make sure we're all checked in. We got all those room templates modified. So we're going to say add block toggles at key level increases. So that's kind of it for tonight. I want to thank everybody for joining, as usual. It's very good to have you guys in chat, and I hope this time works better for everybody. It seems like we got a little bit more activity this time, which is great. Love to see that. Yeah. Instead of a door, it could be a tiger. That should be it. I'll hang around for another like 5 minutes or so and answer any questions you guys might have. Be a little bit more on top of chat than I was during the stream, just because, you know, I kind of get into the zone. Yeah, no problem, guys. Definitely seems like the evening streams are better for a lot of people in general. So the first time we did this, I just picked 11:30 in the morning because it seemed like a good idea, and I really just wanted to get started doing it. We talk about it a lot on the podcast that we have trouble kind of getting started sometimes, and so I've been trying to be better about just jumping in and doing stuff. But by the same token, I also want to make sure that I don't just commit to whatever the first idea I had happened to be, because it may not be the best time and the best day or whatever. But you know, as always, feedback is welcome. You can always join our community online at forum.lostdecadegames.com. You can tell us your thoughts on the streams, on the podcasts, stuff you'd like to see us stream, that kind of stuff. Yeah, the mechanisms are going to be a lot of fun. I think I showed them off on the stream maybe 2 weeks ago, how they actually just worked in game. You know, how you press a button and the wall goes down. And now, you know, it'll be fun to get those things, you know, into a map working in the way that they're intended. So we will do that on next week's stream. And I'll probably do a little bit of prep work just so I make it a little easy peasy. And we'll go over all the stuff that I'm doing. Something else I'm thinking about doing is maybe some shorter form kind of Unity videos, just talking about maybe some very specific stuff that I've been learning. Talking either about our usage of sprite tile or how to do 2D character animation with blend trees, or even maybe some of the new 2D features coming down from the Unity native stuff. So, cool. Well, again, thanks for coming, everybody. It was great. If you like what you see, then, you know, subscribe to Twitch, subscribe to YouTube. We export all these videos so you can watch them later if you ever missed them, or if you want to go back and catch a rerun of something I did earlier that either you missed or you need to watch again or something. As always, if you like what you see here, it's all from our game, Wizard's Lizard. It's on Steam. You can check it out at wizardslizard.com, and you can get all the info there and get it on Steam or through Humble DRM free. Anyways, thanks for joining us, and we will see you next week. Ship it.